Okay, in this video, we're going to talk about scientific notation and significant figures. So first, we want to look at those exponents. So my exponents are these little things. They're a superscript if you're typing them, because Superman flies. So if the exponent of 10 is negative, so like this, where it's -5, the number itself is going to be less than 1. So if it was written all the way out like this, the number is less than 1. If the exponent is positive, like this one right here, then the number is greater than 1. When we write scientific notation, we must keep one non-zero number. So again, 1 through 9, before the decimal. Now we can only have one. I know in math you may have learned that you can have more than that. True scientific notation, you can only have one number before that decimal. So we're going to look at how we convert a number into scientific notation while still maintaining our sig figs. So let's hop down here and check out number 1. So I am going to first look at my sig figs. So this is a Pacific because there's a decimal that's present. So I'm going to start on my left. 1, 2, none of those count, but 5 does count. So I need one sig fig. So 5 is the only number I'm going to be able to use in my scientific notation. So I'm going to say 5 times, and I need to see how many times I've moved my decimal. 1, 2, 3, 4. This number is less than 1, so it needs to be negative. Let's check out number 2 here. Again, I'm going to look at my sig figs. Decimal's present. I'm going to start on the left until I come to my first non-zero number. And everything else in that direction is significant. So I need both of these numbers to be in my scientific notation. I need one non-zero number before the decimal, and then we're going to put that 0 there. And we had to move our decimal 1, 2, 3, 4 times, and that's less than 1, so I need a -4. Let's check out number 3. There's no decimal present, it's absent, so we're going to start on our right side until we come to our first non-zero number. Then everything else in that direction is significant. So those are the 3 numbers I need to include in my scientific notation. So 5.05 times 10, and we had to move our decimal 1, 2, 3 places. Since this number is greater than 1, my exponent is a positive 3. Let's hop over here and look at 7. So decimal's present. I'm going to start on the Pacific, my left side, until I come to my first non-zero number, which is 2. Then everything else in that direction is significant. So I'm going to say 2.5 times 10, and we moved our decimal 1 time. And this is less than 1, so it's going to be a -1. Looking at this one again, I'm going to check my sig figs. Decimal's present, so I'm going to start at the Pacific. First non-zero number. So again, 2.5 is going to be in front there. We had to move our decimal 1, 2 times. So -2 because that number is a less than 1. Number 9, we still only have those 2 sig figs. But now we've had to move our decimal 1, 2, 3 places, -3. So notice all of these first numbers are the same, and all of them have 2 sig figs. But their numbers are different, and in scientific notation, that's represented here by the exponents. Let's check out number 10. So no decimal, so it's absent. So I'm going to start on the right side where the Atlantic is. 0, 0, those don't count. So 5. So I only have one sig fig here. And I had to move my decimal 1, 2 times. This is greater than 1, so it's going to be a positive 2. So again, this only had a 5 in front, but the numbers are very different because of my different exponents. Now let's check out number 11 here. So my decimal's present, so I'm going to start at the Pacific. 5 is significant, so everything else in this direction is significant as well. So I'm going to have to put 5.1, 2, 3, 4 zeros times 10. Now I have to start where my decimal is, 1, 2, 3. And since this number is greater than 1, this is going to be positive. Give these 4 a shot. Pause the video, give those 4 a shot, and then come back and check your answers. Okay. There are our answers. See what you got. If you have questions on those, please let me know, and we can check those out. Now, the next thing that we're going to talk about is taking it out of scientific notation. So sometimes that can be helpful if you're trying to get a better idea about the number. So let's go ahead and check out that bottom section. So we're calling that standard notation. So standard notation is what you're used to writing a number as. So here I have 1.5 times 10 to the third. So that's a positive number, so we know that we need our answer to be greater than 1. If it's positive, I'm going to be moving to the right. 1, 2, 3. To fill in those blanks, we're going to put zeros. Now remember, you cannot put a decimal after that because these 2 zeros are not significant. So watch that as far as sig figs go when you're converting back to standard notation. Now number 2 is still 1.5 times 10, but this time it's to the negative 3. So since it's negative, I need it to be less than 1, so I'm going to move to the left. 1, 2, 3 times. Now, I like to put a 0 in front just to help me see, but I need 1, 2 zeros and 1, 5. Looking at this one, I have a negative 4, so I know negative, I'm going to move to the left, and I'm going to do so 4 times. 1, 2, 3, 4. So I have 0.123 zeros in front, 3, 7, 5. Give that last one a try, pause the video, and then check yourself. There is your answer. Again, if you have questions, let me know.